What's up, Joe 200? How are you? All right, it's Sunday, September 24th, 2023. It's a beautiful day today. It's so gorgeous here. Look, check out the back window here. It's just all sunny, but it's really, really nice outside, man. Isn't that great? Beautiful. Okay, so um, what are we doing today? All right, so we're gonna continue on with the course. You guys have gotten your first writing assignment in. You guys have done great. Learn how to do a little data acquisition, data analysis, okay? And so now we're going to continue on with our journey about relevant biology. All right, and let's go right into it. All right, very cool. So just kind of a reminder of where we were here. So we start out with, looking at aging and how aging kind of sets us up for a lot of diseases. And we talked a lot about it. We looked at some of the world issues and then our immediate issues in terms of our federal government, state governments, local government, and then you as an individual in terms of dealing with these non-communicable, meaning you don't catch these diseases, okay? COVID was a communicable disease, is a communicable disease, hasn't gone anywhere. And these non-communicable chronic diseases of aging that take oftentimes 5, 10, 15 years to have the significant consequences in terms of affecting your health and your lifestyle. All right. So we set it up with aging. So the biggest risk factor is aging. It's the aging process that sets it into motion. There's a lot of theories going on here. That's why we call it theories of biology of aging. And then when we look at the diseases, we know why certain things are happening, and we kind of have a good feeling of why aging lets these things happening, and that's what we're setting the table for. All right. So when we did the theories of aging, just to kind of remind you what's going on here, okay? We did look, that was a great video here. We looked at this rather thick PDF file, okay? And I'm just going to bring it up here about the theories of aging because it's very relevant to what we're going to be talking about today, and that is diabetes and the complications that happen because of diabetes, okay? So as we were going through what was going down with cancer, we were talking about how nutrition, overnutrition, remember what they called it the endocrine or the hormonal basis, and with the overnutrition, basically the cells in our body are told, look, there's all this food coming in. We're going to press the go pedal for you to take up the food, and then while you're at it, since you have the food handy, you might as well undergo a lot of cell division. Okay, you're producing new skin cells every couple minutes. New white blood cells every single second, new red blood cells every second, new gastrointestinal cells every couple minutes. So it's this ongoing process. Okay. And so if you got the goods, okay, the building blocks, you might as well go forward, all right? The problem was with overnutrition, there's that gas pedal for growth is all the time. Remember that was that hormone that was described as called insulin-like growth factor. And then the other one is insulin, okay? So we're going to talk about insulin today because diabetes. The other thing that's shown right here is they talked about cross-linking in this theory, okay? And what happens if you kind of nilly-willy attach glucose to everything, weird parts of the surface of the cell, proteins, glucose attachments to the DNA and the RNA, so all these glucose attachments, but especially the glucose attachment to the proteins that are on cell surfaces and also the proteins that are in your blood, and you have a ton of proteins in your blood. Your liver's always putting these proteins out in your blood that serve these different jobs. They may never get used. It's just kind of a just in case. Here you go. Here's your army men to get it done. Okay, your militia, so to speak. All right. But when they get glucose attached to them, they call, we do, there's a, kind of a purposeful acronym. It's called Advanced Glycation End Product, or AGE. We're studying age, okay? These happens more as we get older, okay? But what it does is now the proteins are not able to do their jobs anymore in your blood or on the surface of the cell. And what happens is your immune system looks at this, and this is called this cross-linking kind of concept, okay? Just one example of it. The immune system looks at the basically honey baked ham proteins, glucose all over the surface, and says, you know what, that looks a lot like bacteria, and it attacks it. Okay, so now you have high blood glucose, you have your immune system being hyper activated, okay, and this is not a good thing, okay. And then what happens then is, like I said, it attaches to any cell. It's, when do you get high blood glucose? We're going to talk about it. It happens with diabetes. So now your blood, everywhere there's blood, okay, artery, smaller branches of the arteries, the arterioles, the tiniest branches, the capillaries, okay. Every one of those pipes is basically lined with cells right here that allow the entry and exit of stuff into your tissue, like your brain and your heart. Anyways, every one of those pipes then gets these candy-coated proteins. The immune system flips out and starts attacking it, and you have this major inflammation, abnormal response to the inflammation with this abnormal repair, and next thing you know, you have your artery that's like this, but what happens is you start getting a clog in the artery. So this right here would be the clog from diabetes. That's called atherosclerosis, okay? And you see the hole is getting smaller and smaller and smaller, and then when it clogs completely, then the tissue no longer gets glucose or oxygen, and it begins to die off, okay? And it gets necrotic. That's called an ischemic event, okay? Happens in your heart, then you have a heart attack, and you have cardiac failure. Happens in your kidney, you have kidney failure. Happens in your brain, you have a stroke. All right, so that's the background on this, guys. All right, so it is relevant to this theories in biology, because we see that this property of this abnormal binding up of proteins, okay, part of it is from glucose, another is from oxidation that gets triggered when you have high blood glucose and you're a diabetic. And then what happens to proteins don't work as well anymore, okay? And get high blood pressure because of that, on and on and on. And we'll see why that matters, okay? All right, so that's the prelude, right? So let's go into our diabetes module. Again, this video right here is going to be stuck right in underneath that topic right there, just to remind you. Alrighty, this is an older publication, 2015, by the American Diabetes Association. They haven't replicated it. It's really, what I love about it is its simplicity. It's not 100% accurate, but that's okay. It's really easy to understand, and that's what's crucial to that. So we'll just kind of flip through that right now, okay? Then this right here is looking at the impact of diabetes, which is gigantic worldwide, okay? Sadly, it's counter to our evolution. We'll talk about that in our discussion, okay? Basically, we've been around, cruising for millions of years as human beings, okay? Our ancestors, modern man about 40,000 years, and it wasn't really until the last couple hundred years that suddenly we have unlimited access to unlimited food, okay? So, our, genetics, we're animals, just like my dogs over there. You're driven to eat everything that you find, okay? And because realistically, our ancestors would then go through large periods of fasting, not because they wanted to, just because there wasn't any food around. And they would then, go cruising around through the mountains or through the prairies or whatever, and trying to find new sources of food. They would stumble upon something, everybody would rock, and then you would, and so this is what we're designed to package fat and have obesity. In fact, the people that were able to package the fat better were the ones that were more likely to survive, okay? So there was a huge advantage to somebody that could put on weight as fat, okay? Now we fast forward to the current situation, and we got a different dilemma. You have to psychologically say, okay, I think I've had enough, it goes against the grain of who we are as animals, okay? All right, so that's the background. Let's go ahead and download this PDF file here. Cruise right in. Pretty simple stuff. We're going to give ourselves kind of the diabetes 101. It's a lot of pages, but you know, don't be freaked out by that. Okay. All righty. Cool. All right. So what do we do when we eat? Okay. So you know, basically there are certain building blocks to our food. So we have complex carbohydrates. This is the rice and the pastas. We have simple sugars. Okay, which is of course candy and the sugars that are found in fruits. Okay, and of course we have figured out how to extract those fruits to make the granulated sugar. Okay, we have proteins that we turn into amino acids. We have fats. Okay, that we digest into individual what are called fatty acids, and then we package those as triglycerides, and we're off and running. Okay, so those are the major elements, and then what we do is we manufacture the components of the DNA and the components of, for the aficionado, the RNA that we use for as a recipe for making protein. All right. So that's what happens when we eat. We digest those components, turn them into their most simplest entity, we distribute them, and then we repackage them and make the protein and the complex sugars and the fats. All right, cool. All righty. So we have this normal level of blood glucose. Okay, um, and you should be staying with that normal level. And how does your body stay in that normal level? Well, we have these control systems. Okay, where when you have a meal, you secrete insulin. Okay, it's your pancreas, and the pancreas senses the level of blood glucose after a meal, and poof, out goes the insulin. Okay. And then when there's no glucose around, okay, the pancreas, another type of cell, that's the beta cell that secretes the insulin, the alpha cell secretes another hormone called glucagon, and glucagon runs down to the liver. The liver is your little warehouse where you store a lot of the glucose when you're not using it. And it says, hey, remember that stored glucose? Bring it on, okay? And off it goes, okay? The blood glucose rises, insulin then gets secreted again, you package it away and use it. It's just kind of this constant cycle of what's going on, all right? Alrighty, insulin's important, okay? You got it because you need to put glucose into your cells, and it gives not only the energy, but we can then use it to make other cells, okay? Super good stuff, okay? High blood glucose, that's called hyperglycemia. When's that gonna happen? Well, we have a couple different conditions, all right? We're gonna learn about type 1 diabetes and type 2 diabetes. Type 1 diabetes is also called juvenile onset. It happens in younger people. It is an autoimmune disease, and autoimmunity is a really, really difficult disease. There are a lot of autoimmune diseases and a very difficult kind of scientific problem in terms of why this is happening, okay? But we do know the immune system will attack the pancreas and destroy all the cells that produces insulin. And now you're completely 100% dependent on insulin injections, okay? Why can't I take an insulin pill? Because insulin is a little protein, okay? Remember what I told you, what happens to protein? You put protein in your mouth and goes down to your stomach, you digest it into amino acids, all right? So that's not going to work. So that's why we have to bypass the gastrointestinal system. We have to inject insulin directly into your artery or vein, okay? All right, so that is type 1 diabetic. Type 2 diabetic, okay, this can be insulin dependent late in disease, and I'll get into that later, but it is because of a genetic vulnerability and a lifestyle of not enough exercise and too much nutrition that leads to insulin receptor insensitivity. So now your body's producing the insulin, but the receptors are really crappy at recognizing. You know, normally here comes insulin, here's a receptor, boom, the second it binds, all these crazy things happen, wonderful things happen. So the glucose goes in the cell, you manufacture what you want, it keeps you going. You know, you're like a fine-tuned machine, okay? But if now in comes the insulin, and this is what my insulin receptor looks like, okay? It doesn't bind so well, and so the glucose stays really high in my blood. My cells are starved for glucose, so you'll look at the symptoms we'll talk about where you're weak, okay, and you're tired, and then you have all that glucose in your blood that causes the immune system to flip out because you start inappropriately candy coating things. All right. So, what are the symptoms of hyperglycemia? And it can happen with either type 1 or type 2 diabetes. Right. Type 1, all right, you forgot to take your insulin. You forgot to inject yourself with insulin. All right. Your pancreas can't produce it. So now So what happens is you're really thirsty. Why does that happen? All that glucose in your blood goes running down into your kidneys pushes it in your bladder, and glucose, if you ever taken sugar and you put it into water, you stir it up, it magically disappears. Where'd that sugar go? What happens is all the glucose molecules are surrounded. In the case of sugar, table sugar, it's sucrose, and it's surrounded by water. It's suddenly transparent. Well, the same thing happens in your body, all right? So the glucose that's in your blood is surrounded by water. It goes into your kidneys, and you then put it in your bladder and you pee it out, okay? So you're peeing all the time. As a result, you're dehydrated and you're really thirsty, all right? Okay, all the blood vessel problems that I was talking about causes blurred vision, all right? Major blood vessels in your eye. In fact, one of the big complications that happens is blindness because of diabetes. Again, this is not immediate. This is over a 20, 30-year period. But once it's happened, there's no reversing it, all right? They call that diabetic retinopathy because the back of your eye is called the retina, okay? You're feeling tired. Why is that, okay? The glucose is in my blood. It's not getting into the cells. Either you're a type 1, you don't have the insulin, or a type 2, and the receptors are not recognizing insulin as well, okay? Bad news, okay? So then you start having really, really bad compromise to all your blood vessels. Like I said, the immune system flips out. You start getting remember, here's my nice, big, old, beautiful blood vessel, and here's my atherosclerosis getting worse and worse and worse, okay? Alrighty. That means you can't deliver the immune system down to cuts and wounds, okay? So they don't heal, all right? The high blood glucose is not great for your immune system to begin with, so you start having wound healing issues, okay? You start having infections, okay? Now, worst case scenario, once you become a diabetic, you can't get the glucose into your muscle cells and you start to waste away, okay? So you have weight loss, okay? And again, worst case scenario, it begins to affect the brain and it induces vomiting and nausea. Okay, all righty. So chronic complications, okay? This is, you're a diabetic for 30 years. It's hard to wrap your head around how important this is, but if you're looking at your parents and grandparents, if diabetes runs in your family, that means for the same approach to life, you're much more likely than to have this insulin receptor insensitivity. It is what it is, okay? And so blindness because of vasculature problems, kidney disease because of the vascular problems, nerve damage, vascular problems, okay? You can't get blood flow to your toes, your feet, your legs, amputation because the tissue becomes necrotic, okay? Blood vessels to the heart not working, heart attack, blood vessels to the brain not working, stroke, okay? Alrighty, so like I said, type 1, this is a juvenile onset and autoimmune disease, okay? No insulin, okay? So we have to inject resistance. Type 2, all right? Cells don't use insulin because the receptors are not working. This is called insulin resistance, okay? The pancreas tries to compensate and starts pumping out the insulin initially, so you actually have super high levels of insulin, which is a risk for cancer, okay? And then, however, ultimately, what happens is asking the pancreas to work that hard causes it to fail. So late stage type 2 diabetics also need insulin injections, all right? These numbers are changing because of our country is having more and more of a problem. It is completely linked to obesity in terms of type 2 diabetes, okay? This is type 1 diabetic. This is, again, these numbers are more stable. This is an autoimmune disease. There are things like a viral infection that can precipitate this, okay? So we may see more, in fact, we are seeing more type 1 diabetics because of a consequence to being unlucky in terms of how your body has responded, your immune system has responded to the COVID infection, okay? Like I said, people are much younger, diagnosed under 20 years of age. You can't produce insulin, so insulin injection is the treatment, okay? Alrighty. We went through these symptoms, okay? This is the worst case scenario right here. You can cause somebody to slip into a coma, okay? What happens is if you can't get sugar into your cells because you don't have insulin, you begin to burn fat and you burn protein, okay? This condition It's something that we try and do sometimes when we're dying. Okay, you guys have heard of ketogenic diet. Okay, how do you go? What is a ketogenic diet? No carbs. Okay, no sugar, no insulin. Okay, and so what you start then doing, you start burning fat. That's a whole different game. Okay, which when you burn the fat, you make these ketone bodies that lower the pH of your blood that can cause all these problems. All righty, cool. All right. So as a type 1 diabetic, okay, you have to monitor your glucose. Back in the day, you had to do a pin prick, okay, and you had this special device that would directly measure the glucose content in your blood, okay. Should be right around 100, okay, called 100 milligrams percent, okay. If you start getting to 200 or 300, you're in trouble, okay. Now, okay, the beauty of science, there is a little patch, a little device. It's like a little kind of knobby device. It's about a quarter and eighth inch thick, about this big around. You stick it on your arm, and it gives you constant monitoring of blood glucose indirectly by looking at changes in actually the flow of electricity across your skin. It's very complicated, okay? But yeah, so it's really cool that there are these new methods, okay? People need to understand how to manage it through education, okay? How to inject yourself with the insulin, healthy food choices so you don't have spikes in activity. This shows you right here, again, the wasting away of a child. Old school pictures, okay, 7 years old, and then 3 months after insulin therapy. Why was he wasting weight? Couldn't get any sugar into his cells, okay? All right, most people, okay, 95% of the diabetics you're gonna encounter are type 2 diabetics, okay? These are people over the age of 40, 50, 60, okay? This is more common the older people get, okay? We're seeing it in younger adults. It's a huge issue, okay? The Surgeon General made an announcement this last year about the obesity epidemic, and the prediction is by 2030 that we're going to have 40% of our country is going to be diabetic, which is mind-boggling, okay? Right now, we're between 20 and 30, all right? All right. Being overweight is a huge risk factor, okay? Because of the fat and the inflammation of your fat releases contents into the blood, and then this goes to all those receptors that I was talking about, okay, that are supposed to recognize insulin, and it makes them not work as well. They become insensitive, okay? So it's insulin receptor insensitivity, okay? We see it more often in non-Caucasians, okay, in other ethnicities, okay. This has a lot to do with family history, okay, culture, and this changes, okay. Awesome. Alrighty, same symptoms, okay. You still have too much sugar in your blood. You're still peeing it out, so you're going to be thirsty. So urination. You're not getting the sugar into your cells, not into your brain, into your muscle cells. So you have major fatigue, and all the other things we talked about before right here, okay? Awesome. Education is key. Eating healthy is key, okay? You can stop type 2 diabetes in its tracks, okay? You are predisposed, okay? If you're, once you get it, you're kind of on that treadmill. However, you can really minimize the amount of drug therapy you can do by eating healthy and exercising, and you're going to be asked to use the proper medications, okay? All right, risk factors, obesity. Fat is, okay, basically an inflammatory organ that also releases free fatty acids into the blood. The more fat you have, the more free fatty acids in your blood. Those affect the way your insulin receptors perform. If you have lots and lots of inflammation, okay, that affects the way insulin receptors perform. They become resistant and insensitive to the actions of insulin, all right? So that's why these things are so important. Family history, all right? It is what it is, okay? I have arthritis, okay? That's our cross to bear is what they say, okay? So the same level of activity would not have generated arthritis in other people. It's just the way my body responded, okay? Alrighty, And we can see the high risk groups right there. Okay. Again, we're always looking backwards, okay? We can see cultural tendencies in our country, okay? So we see here in the southeast, okay? It's hot, it's very hot. Did I say it was hot? It's hard to exercise all the time. The food there, savory, okay? But also high fat. Obesity tends to run in these parts of our country, all right? All right, so we see obesity and diabetes going neck and neck, okay, based on what you would call kind of the geographic or the hotspots, okay? All right, so these are just some stats from a while ago, and it's worse and worse and worse and worse, and we'll go over that in a second, okay? Huge financial burden, okay, because of the trajectory of multiple diseases because of diabetes, all right? Okay. Prediabetes means that your blood sugar is oscillating. Okay, you're gonna look at a couple different measures. You're gonna look at your resting blood glucose. The physician who's an endocrinologist who's working with you, who specializes in diabetes, will ask you to do what's called a glucose challenge test, where they give you a set concentration and number of sugar molecules, ask you to drink it, and then they will measure your blood glucose 2 hours later. So that's a measure of how well you produce insulin and how well your insulin receptors work, okay? And then the other one is more of a chronic measure, and it's a measure of those candy-coated proteins I was talking about, and that's the hemoglobin A1C or HbA1c. Those are the three measures you're going to be looking at, okay? So yes, you can control things. That's the good news. You have the opportunity to be preventative, okay? Here's your A1C, okay? This is a percentage right here. So you want to be less than 7. Really, the recommendation is 6.5, okay? You want to have lower blood pressure, okay? So you guys are young. You should be sitting around, I don't know, 110, 120. That's when the heart contracts, pushes the blood out. That's the systolic blood pressure. To maybe between 60 and 80, and that's the resting blood pressure when the heart is not contracted. Manage your cholesterol. Stop smoking. Stop smoking. Stop smoking. Okay. Be active. Just make healthy food choices. It doesn't have to be all the time, but there are people out there that basically have McDonald's 3 times a day, 7 days a week. Okay. Once you are a diabetic, you have to have really good hygiene and keep your screenings. Okay. Alrighty. And this just talks about education and research. Awesome. Okay. So nice walkthrough right there. Okay. We come down here. This is a world report. Okay. It's the Diabetes Atlas. We can get right there real quick just to see what it looks like. Okay. We're going to go right into it, man. And this is just, just for your edification. So you can go in here and you can do all kinds. This is the International Diabetes Federation, okay? And it has all kinds of information that I want you to check out, all right? So we scroll back here, okay? We'll go back into the highlights that we posted right here, okay? So you can look at your friends all across the world here. And so these are the numbers, okay, that were posted in 2021. They're constantly updating in terms of how many people have diabetes. And these are the people that have lots of disease, okay, lots of what's called morbidity, and it's the leading cause of death as well, okay. And so we see the global findings, okay. We see that there is a socioeconomic component to it, so people don't get access to great food. We have food deserts in our country. There's a huge socioeconomic component to it in our country, okay, and it's a major cause of death, as we see right here. And we're going to go into the trajectories as to why. If you want, you can check here, right here, and you can look at us, okay. So 20% of us, okay, 25%, sorry, of us are living with diabetes, okay, and not diagnosed, okay. This is the official amount right here, but realistically, many poor people are living with diabetes. Officially, 1 out of every 10, okay, but realistically, we're closer to between 20 and 40% right now, and it's just going up and up and up, okay. Alrighty. So when we look at this, okay, what do we see here in terms of diabetes? Because of the candy coating of your blood vessels and the inflammation. The blood vessels do not do this, okay? Every time your heart contracts, your blood vessels go like this and then push it, go like this and then push it. Every single blood vessel all the way down, nice and flexible. When they get candy coated and inflamed, they become very rigid. You have blood pressure. This causes injury to the blood vessels. Then the inflammation, the immune system tries to repair that injury, also tries to get rid of the glucose, and combined with high cholesterol, that will get in there and form these plaques, okay? So these are all these causative factors, okay? Obesity, like I said, is the big one right there for all this, okay? And lack of activity. What are the consequences when you have this, okay? When you have these blood vessel issues, like I said, heart attack, stroke. If you look at down into your legs, that's called peripheral artery disease. That can lead to amputations, okay? And lots of pain, right? So control your A1C. That's a chronic measure of your blood glucose, okay? That is indirectly an advanced glycation end product. Eat veggies, take your medicine once you've been diagnosed. You got to keep it under control, okay? Exercise, okay? Like I said, here we are, 40% Americans, okay? Right now, it could go up to 60%. It's mind-boggling, okay? You know, this is the eyes, the diabetic retinopathy, and this is some stats on that, all right? Here's two different videos, okay? This one explains to you what goes on in terms of the insulin receptor, the type 2 diabetes, the insulin receptor insensitivity, how it works, okay? And there are a lot of different aspects of your physiology. High levels of fat in your blood contribute to the kind of disconnect between insulin binding and the ability to put these little channels in here to suck the glucose into the cell. High levels of inflammation do this as well, okay? And this is where the immune system is inappropriately in high alert, all right? Higher levels of growth factors from overnutrition contribute to that. This is John, okay? He talks about his major complications, okay? So diabetes unto itself, you're dying from diabetes because of the consequence of these complications, okay? So you can have a stroke and die from it. Why did that person have a stroke? It's because initially it was diabetes that then led to vascular disease. We're going to talk about next week. And then when the vascular disease gets worse and worse and worse, okay, this happens. And so no blood, no oxygen, no glucose, death, okay? That's what happens when you have coronary artery disease, okay? That's your heart, all right? And you don't have blood flow to the heart then begins to die off. The extremities, okay, this is the peripheral artery disease or peripheral vascular disease. Again, you get infections. The tissue doesn't get enough blood flow. It begins to die off, okay? Neuropathy, okay, that happens in the extremities as well. It can be very painful, or you lose the sensation of touch. You can't even tell what's going on there. Sadly, one of my good friends has a neuropathy, and just when you close your eyes and you see, I can tell I'm using my first finger, my second finger, my third finger. What happens with neuropathy is you lose that sensation, and so you don't realize how much you need that to walk. And now she is really having a little trouble walking. Kidney disease, people lose their kidneys. Okay, they have to go on to dialysis, sign up for a kidney transplant, and then people go blind. All right. Doesn't sound good, and this is why it's super important to just integrate lowering your stress, okay, yoga, okay, hanging with your friends, going out into nature, having a really good diet, okay. It's okay to splurge, okay, just don't make it like that all the time, and then just have a regular exercise routine. You owe it to yourself, all right? Okay, so this is this concept of where the obesity is coming from. Excuse me. And again, it's one of those things that we look at our ancestral animal drive to eat. Okay, so then what insurance companies have done is they look at your body mass index, and all that is looking at your weight relative to your height, which is really not fair if you're an athlete. Okay, you're just very thick boned and really muscular. Okay, so I show Patrick Mahomes, LeBron James here, okay, have really high BMIs, but are at the peak of optimal human health, okay? That being said, this is what we have. We have this body mass index. It's what's used by physicians. It's also used by insurance agent companies to determine whether or not they're going to charge you more for your insurance. Okay, this is a pretty cool article on MedPage today as to why BMI is slowly going out of favor. Okay, it's just so easy to measure. That was the problem. Okay, and so it goes into where we had BMI, where it came from, but how it goes into more direct measurements of body mass and looking at the hip to waist ratio, and then there's other ways of looking at your actual fat content in your body. So that's what that's all about, and hopefully that's in our future. All right, so we want you to do your BMI, okay, and that's what this is all about right here, okay? All right, so the other thing we have here, okay, is your ability to look at your life expectancy. So we have the body mass index calculator, okay, right here, and then you can go and do a life expectancy calculation, all right? So this is offered up not only in the NIH, but also it's offered up through these insurance companies. So what we want to do is to go ahead and do this as well, all right? So I was born in 1956. If you go to the Social Security Administration site and compare that national average for John, compare it to your own, post in your discussion, and talk about the BMI too. Okay, so that's what this is right here. All right. So this is my calculator right here for looking at other things. I want you guys to show some curiosity. Okay. Alrighty. So read through this. Have fun. It's a good topic. Okay. All right, guys. So I think I'm just gonna end right there. Peace. We'll see you guys next time.